Let's be real. In a world of nonstop cyber threats, how do you actually build software that's secure from the ground up? It's a massive challenge. So today, we're going to look at a blueprint that's been the gold standard for more than 2 decades, and it shows us how the pros build security into the very DNA of their products. So let's start with a really fundamental question. When you picture a security failure, what pops into your head? A hacker in a hoodie? A single weak password? The real question we should be asking is, where does that very first crack in the armor actually appear? And the answer? Well, it's as simple as it is terrifying. It can start anywhere. A security risk isn't just one single event you can guard against at the very end. Nope, it's a constant threat that can creep in at literally any point in the entire process of creating software.
And that really gets to the core of the problem. You can't just bolt on security after everything's already built. Think about it like this. You wouldn't build a massive skyscraper and then try to make it earthquake-proof, right? That would be crazy expensive and it probably wouldn't even work. Security has to be in the blueprint from day one.
Okay, so if security needs to be in the blueprint, what does that blueprint actually look like? Well, for a lot of the world's biggest tech companies, the answer is the Microsoft Security Development Lifecycle, or SDL for short. It's a structured, formal process for weaving security into every single phase of development. And just to be clear, this isn't some hot new trend. The SDL has been around for over 20 years. It's a battle-tested, time-proven framework that has grown and adapted right alongside the threats, built on literally decades of learning from real-world attacks. The whole philosophy behind the SDL is a huge mental shift. It's about moving security from being that final quality check, that thing you do right before release, to being an integrated, continuous process that's just a normal part of every single stage of development. So what are these stages we're talking about? Well, it's the familiar journey that pretty much any software takes. It all starts with design, where you're planning out the architecture. Then you move to code, where the developers are actually writing the thing. Next up is build and deploy, where it all gets compiled and pushed out. And finally, run, where it's live and operating in the real world. And here's what's absolutely critical to understand. Each one of these stages has its own unique security risks. Back in the design phase, a simple flaw can accidentally create a massive backdoor. During coding, one little mistake could let an attacker completely take control of the application. Even your build and deploy pipeline, that automated process that gets your code to users, can be hijacked. And of course, once the software is running, poor security practices can compromise the entire live environment. Okay, so we get the problem, we get the philosophy, but how do you actually do all this? Well, the SDL is built around 10 core practices that make security a real, tangible thing that any development team can actually implement. The first 5 practices are all about laying a rock-solid foundation. This starts with setting clear rules and standards so everybody knows what secure actually means. It's about making smart choices early on, like using proven, secure frameworks instead of trying to reinvent the wheel. A huge step here is something called threat modeling, which is basically thinking like a hacker to find design flaws before a single line of code is ever written. And crucially, it's about securing your supply chain, because any third-party code you use can easily become your weakest link. Then, the next 5 practices are all about execution and staying vigilant. This means securing the very environment your engineers work in, their laptops, their tools, the whole shebang. It demands continuous security testing, not just a one-off check before you launch. You also have to harden the platforms where your software actually runs. And you have to have a solid plan for monitoring and responding when, not if, something goes wrong. And maybe the most important piece of all, training. Because security is everyone's job, not just the security teams. So the big takeaway here is this. These 10 practices are not a checklist you just run through at the end. They're a framework that you weave directly into the fabric of how you build things. The goal isn't just to produce secure software. The goal is to create a true culture of security. Okay, so you might be thinking, this SDL thing has been around for a while. Is it still relevant? And the answer is absolutely. In fact, it's the perfect foundation for one of the most important concepts in modern security, the zero trust mindset. Now, zero trust sounds intense, but it's a simple, really powerful idea. It all comes down to 3 core principles. First, assume you've already been breached. Second, explicitly verify everything. Never trust anything by default. And third, grant the absolute minimum level of access, or least privilege, that's needed for any person or system to do its job. That's it. And that's the connection. That's the light bulb moment. The SDL isn't just some old process. It's how you actually put zero trust into practice when you're building software. Every single stage, from the first design sketch to final deployment, is seen through that powerful lens. Assume breach, verify everything, and give the least privilege possible.
So, we'll leave you with this question to chew on. Is your software just being built with security sort of hoped for at the end? Or is it being truly engineered for security, right from the very first line of the blueprint? The difference between those two approaches has never, ever been more critical.